What's up guys, it's Timon Fiat and today's video is on grade Chemistry A-Level Alkanes question paper, physics and mathstutor.com. So really I want to go through like the ones like out maybe all of Organic 1 before Friday, and then the ones that have a lot of questions on the question papers. I'll focus on them on Saturday, Sunday, which makes sense since they'll take more time. So question 1, which is a propagation step in the chlorination of methane? Well, the first one, I've got a hydrogen free radical. I would never have that. B, I'm forming a hydrogen free radical. I don't know. No, we're not going to do that. C, that is a termination. Two free radicals to form covalent bond. So that is not it. Therefore, the answer must be D. And it makes sense, and we're forming a chlorine free radical. Question 2, which statement is not correct about the pollutant sulfur dioxide? It can be removed from car exhaust gases by catalytic converter. That is not correct. The rest, power station by reaction with calcium oxide, yes. Cause respiratory problems, definitely. It can cause acid rain, yeah. It can't be removed from car exhaust gases by catalytic converter. Question 3, which statement is correct about thermal cracking? Aromatic hydrocarbons are the major products. No, that is for catalytic cracking. So that's trick you up. Carbon-carbon bonds are broken. Zeolite catalysts are used. No, that's catalytic cracking. So I'm left with A and C. Carbon-carbon bonds are broken. Yes, that is true. Yeah. A pressure between this much is used. No. So the answer is 3C. So D, A, C. Carbon-carbon bonds are broken. Question 4. An excess of methane reacts with chlorine in the presence of ultraviolet radiation. What are the main products of this reaction? What we're producing? Definitely not going to be C and A. Hydrogen. How would we produce hydrogen? We can't. So I'm left with B and D. Well, excess of methane reacts with chlorine. We wouldn't form CCl4. Yeah, we would form CH3 and bond it to the chlorine free radical, so CH3Cl and HCl. The answer is D. Question 5. Give an equation for the complete combustion of octane. Complete combustion, enough oxygen to ensure only carbon dioxide and water form. So that's a general basis. Like if it asked me give an equation for the complete combustion of pentane, I'll just put pentane plus O2 to form CO2 plus H2O, and then the rest is just balancing it. So I've got 8 carbons. I've also got 18 hydrogens, so I need a 9 here. So how many oxygens is that? That's 25, so I need a 12.5 O2 here. So yeah, given the equation for a reaction that removes nitrogen monoxide catalytic converter, 2CO plus 2NO arrow N2 plus 2CO2. Okay, it says sulfur dioxide produced in the combustion of fossil fuels. The total emissions of sulfur dioxide in the UK have fallen dramatically since 1970. Calculate the mass. It is 2 marks, so it shouldn't be too hard. Calculate the mass of calcium oxide needed to react with the mass of sulfur dioxide. Mass of calcium oxide. So what I'm going to do first is I'm going to find out the moles of sulfur dioxide. That is just immediately what I'm thinking of, finding out the moles of sulfur dioxide. How do I do that? Well, it's mass in grams. It's giving me this much in tons, so 6.49 million tons, but I want it in kg, first things first, so that's going to be 1 ton is 1,000 kg, 649 6.49 million tons in kg. So what I need to do is, well, firstly 6.49 million, so that is 6.49 times by 10 to the power 6, and then I need to times by 1000, so it's going to be 6.49 times by 10 to the power 9. But then I need, so 6.49 times by 10 to the power 9, but I want mass in grams. I always want mass in grams. Moles and masses over mr. Moles is mass over mr, where mass is in grams. So I need to times that by another 1000, 10 to the power 3, divided by the mr of SO2. That should be pretty easy. 32.1 plus 16 plus 16. 1-to-1 mole ratio, I can clearly see from the equation. So therefore, the moles of calcium oxide is also going to be that. That's equal to calcium oxide moles. And we want to find out the mass of calcium oxide. Moles is mass over mr. Mass is going to be the moles, which is just going to be that, because they're both the same, times by the mr of calcium oxide. So it's going to be that which is 1.012 times by 10 to the power 11, and I also want to then times it by 56.1. That's the mr of calcium oxide, mass in moles times by mr. Yeah. And I also then, because I want it in kilograms, this would be in grams, I need to divide by 1000 again, and that will give me 5.68 times by 10 to the power 9 kg. So 5.68 times by 10 to the power 9 kg. So you just need to be very confident with converting, and sometimes they'll give you like million tons, in this case nanometers, all of that kind of stuff as well. Just need to know, could be very confident with all kind of units really. So in the exam, if they put an unfamiliar kind of unit, which I doubt they will, but then you at least be prepared for that. It says question 6, which equation represents a propagation step. So the first one is going to be a termination. The second one is also a termination. The third one is a initiation. Therefore, D must be propagation. That's how well you know the differences between initiation, termination, and propagation. Which statement is correct about the fractional distillation of crude oil? A zeolite catalyst is used. No, that is for catalytic cracking. Each fraction, well, actually, look at D. The fractionating column is hottest at the top. No, it's hottest at the bottom. It's coolest at the top. So it's not going to be D. So I'm left with B and C. The answer is clearly going to be B. Each fraction contains a mixture of hydrocarbons. They're not formed by breaking covalent bonds. Question 8. Which equation represents a termination step? Termination step, so I'm going from termination, initiation, termination. So I'm two free radicals together to form a covalent bond. So this one's propagation, this one's also propagation, that one's also propagation. Therefore, the answer must be D, termination. When alkanes are burned in excess of oxygen, they produce carbon dioxide and water. Write an equation for the complete combustion of propane. So propane is an alkane. Alkanes have a general formula CnH2n plus 2. So propane, methane, ethane, propane, C3H double that plus 2. So it's going to be C3H8 plus oxygen, complete combustion, enough oxygen to ensure products are purely carbon dioxide and water, H2O. 3 carbons, I need 8 hydrogens, so I need a 4 here. How many oxygens do I have? 6 plus 4 is 10, so I need a 5 here. So that C3H8 plus 5O2 forming 3CO2 plus 4H2O. Part B says deduce the molecular formula of this alkane. And it says expression can be derived using bond enthalpy data to estimate the enthalpy of combustion of an alkane, where it's equal to that. Enthalpy of combustion of alkane was calculated to be this. Using this expression to deduce the molecular formula is alkane. So what I think we have to do is just let this minus 496n plus 202 minus the brackets and outside equal to minus 6650. And then, well, I guess I can divide by minus 1. 496n equals 6650 minus 202. Get my calculator out. 6650 minus 202 and then divide by 496. Okay, so perfect. So 6650 minus 202 is 6448. I get n is equal to 13. However, it says deducing molecular formulas alkane. Well, it says alkane. I know it's CnH2n plus 2, and I know n carbon atoms, so it's got 13 carbon atoms. Therefore, it's going to be C13H28. Perfect. Bit of a weirdly asked question. And in part C says suggest one reason other than the use of mean bond enthalpies why a value for enthalpy of combustion of a liquid alkane is different from that value obtained using expression part B. Well, part B, it was the alkane is not gaseous. We can elaborate that it takes energy to convert it into a gas. And that we can say alkanes are gaseous in calculations using bond enthalpies. It takes energy to convert it into a gas. Part D says plot enthalpy change for the combustion of 1 gram against the number of carbon atoms. Draw a best fit line and use this to estimate the enthalpy change for combustion of 1 gram of propane. Write your answer in the table. So minus 55.6. You know what? I will go through this one. Why not? Methane. So methane's got 1 carbon atom. Ethane, methane, ethane, 2 propane, 3 butane, 4 pentane, 5. So methane, 1 carbon atom, it's at minus 55.6. Should be something here. Minus 55.1, 2, 3, 4, 5, 6, 7, 8, 9, 56. Perfect. Minus 52, 2 carbon atoms, minus 52. Obviously, that's what we're trying to find. Propane, butane, 4 carbon atoms, minus 49.6. Pentane, 5 carbon atoms, minus 48.7. And then what we'd have to do is draw a smooth best fit curve. Because definitely can't do a line here. So it should be a smooth curve. Let's zoom out a bit. Actually quite a bit. Yeah, obviously that's not smooth, but in the exam hopefully you get it. And you know it should be something like here, minus 50.8. Obviously it depends on your graph. Mine's 51. Part E says, calculate the heat energy released when this much burns in excess oxygen. So heat energy released. So what I'm going to use Q equals MC delta T. But I don't know the temperature rise, do I? No, I don't. But I have enthalpy change, so what I think we're going to have to do is use delta H equals Q divided by moles, and therefore Q equals delta H times by moles, and moles is mass over mR. Okay, so we've got a blueprint now, a path of what to do now. So I already have delta H enthalpy change 47.8. I don't care that it's negative, that just tells me that it's exothermic. So I know delta H 47.8. Include this in brackets. Okay, and it's in kilojoules, and I want my final answer in kilojoules, so that's fine. Now I need to find out the moles of mass over mR. Now I know density of this much centimeters cubed and this much. So what I'm going to use is density is mass over volume. Mass is density times by volume, which is going to be 0.692 times by 1 divided by 1000, because I want to convert from dm cubed to centimeters cubed. That will give me the mass, and then I do the mass divided by the mR of isooctane. And yeah, so am I given the 2,2,4-trimethylpentane? Or wait, yeah, find out the mass of, so let's do that. So it's going to be 0.692 times by, oh no, I'm not doing 1 divided by 1000, because if I want this in centimeters cubed, I'm not dividing by 1000, I'm going to times by 1000, so times by 1000. So I get the mass equals 692 grams in grams. And I want the heat energy released. Well, trimethylpentane, mR of isooctane, well, I know it's octane, so it's going to be C8H18. So I'll work out the mR of that. So it's going to be 692 divided by 12 times by 8 plus 18. That'll give me the moles. I know delta H is Q divided by moles. Q is going to be my moles times by delta H, which is 47.8. And I get, yeah, I get something else. So let's see what I could go wrong. not sure. Okay, I'm gonna mark this question down. Maybe I've attempted it completely wrong. Who knows? So I will definitely probably do this in a separate video, but that's great because now I know there's a question here that I struggle with. So what I'm gonna do is get rid of all this, take a quick screenshot of it, and then find out what to do. Okay, so that's enough. Okay, let's carry on. Question 10, which equation is a propagation step in the conversion of trichloromethane into tetrachloromethane by reaction with chlorine in the presence of ultraviolet light? Propagation step, well, A, that's nothing, there's no free radical propagation. B is termination. C is a propagation, but you form a hydrogen free radical, therefore it cannot be correct, therefore the answer must be D. Question 11, which row is correct? A, thermal cracking, high pressure, high temperature, no. Slight, no, well, actually, no. Products, mainly alkanes, no. We form alkenes. B, form mainly alkenes, slight pressure, high temperature, no. It's high pressure, high temperature. High pressure, high temperature. Mainly alkenes, that is correct, but this is incorrect, so yeah. C, catalytic cracking, okay. Mainly branched alkanes and aromatics. Yes, that is definitely correct. Both C and D both have them as the same. So it's between the conditions. Slight pressure, high temperature, or high pressure, high temperature. High pressure, high temperature, that is for thermal cracking. This row is about catalytic cracking, therefore the answer is C, slight pressure, high temperature. That is the correct conditions. Question 12, which catalyst is used in the catalytic cracking of alkanes? Catalytic cracking, remember, high temperature, slight pressure, we form mainly aromatic hydrocarbons and alkanes, whereas thermal cracking, high pressure, high temperature, we form alkenes. And which catalyst is used? It's going to be zeolite catalyst. And in question 13, which correctly represents an incomplete combustion of pentane. So A is wrong, that's complete combustion, enough oxygen to ensure products are completely carbon dioxide and water. B is, okay, so I'm left with B, C, and D. Well, the thing is with D, we're definitely not going to form hydrogen, so I don't know where it's got that from. So I'm left with B and C. We're definitely going to form carbon monoxide. We are definitely going to form carbon dioxide and water. But which one is correctly balanced? That's what I'm looking for. Well, in this case, I've got 12 oxygens. And how many oxygens here? On the right hand side, 4 plus 2, 6. 6 plus 6 is 12. So, yeah, I would do that. But let's just check B as well. Oxygens here, that is 16. Oxygens here is, well, that's also going to be 12. There's 4 plus 2, 6. 6 plus 6 is 12. So that is not it because it's not correctly balanced. Therefore, the answer must be C. We form carbon dioxide, we form carbon monoxide, we form carbon dioxide, we form H2O, and it's completely balanced. Perfect. And then question 14 says which species is producing the propagation step during the reaction of propane with excess of chlorine. Definitely not a hydrogen free radical. What? How would we form amazing ether butane hexane in the reaction of propane with excess chlorine? Definitely not D. Left with B and C. Clear answer is going to be C. Remember, it is propane C3H6 and also the Cl2, so 14C. Definitely not C3H5Cl, C3H6Cl2. Question 15. Which of these substances does not contribute to the greenhouse effect? Unburned hydrocarbons, that does. Carbon dioxide obviously does. Water vapor or nitrogen, that does. The answer is D, nitrogen. Nitrogen does not contribute to the greenhouse effect. And question 16 says, which molecule is not produced when ethane reacts with bromine in the presence of ultraviolet light? So again, we're not going to form hydrogen, and we're not going to form butane. So those are just two random options to trick you out. So left with A and B, HBr or C2H4Br2, it's definitely going to be, actually, oh my days, oh my days, oh my days. How did I, which molecule is not produced? I thought it said which molecule is produced. Which molecule is not produced? Okay, so A, that will be produced. B, HBr, yeah, it's going to be C, obviously, because hydrogen, you would never form a hydrogen or hydrogen free radical. So yeah, and D, yeah, that will be produced, I guess, since that is not going to be produced. Hydrogen. And that is the end of AQA Chemistry A level alkanes question paper. You know, a lot of key details you need to know about thermal cracking, catalytic cracking, and then the rest, a lot of calculation questions, obviously multiple choice questions, and yeah.